Okay, recording and share the screen. And so I did make a recording. It was rather quick. I just pretty much hit the highlights of everything we needed from yesterday. And so there was a recording. I got it down to under 15 minutes, I think. I just gave you what were the essentials because I didn't have time to do the rest. Okay, tomorrow is a one-day weekend. It's flex day, so no class tomorrow. We'll meet again on Friday. I'll give you a quiz, and most likely scenario for the quiz is I'll give you something like this where you'll find the 6 trig functions of the angle theta. Okay, so I'll give you 2 out of the 3 sides. You have to use the Pythagorean theorem to find the third side, right? So like problem 1 or 2 or any of these things. And then I'll say find the 6 trig functions, sine, cosine, tangent, cotangent, secant, cosecant, right? So it shouldn't be that bad. That'll be the quiz. All right, and as I mentioned, I'm actually quite a bit ahead. I was very close to finishing section 4.3 even, which was not scheduled until next week sometime. So I was going to do the problems at the end. They are word problems. I was going to show you 19, 21, and 25. I would be essentially done. So I'll sneak in a little bit of 4.4. I always believe in going a little bit ahead if possible rather than just stopping. So I'll sneak in the introduction of 4.4. It'll make it easier for me on Friday, not tomorrow. We're not meeting tomorrow. Tomorrow's flex day, but Friday. Okay, so again, we're probably going to finish early. So think of any questions you might have. You can put it in a chat or unmute yourselves a little bit later. But otherwise, we'll be done fairly early today. So I can take questions if you have any. So think of any questions you might have after I finish what I want to do from 4.3 and then my introduction of 4.4. Okay? That's it. So again, we've already gone ahead. So I was only scheduled to do 4.2 for the week, and I'm past that. So anything that I do beyond that is gravy, so to speak. Okay, and I'm almost even done with 4.3. And maybe I'll sneak in some of 4.4. So we're a little bit ahead, but that's okay. All right. So back to 4.3. We have some word problems at the end. Okay, so 19. Estimate the distance around the Earth at 45 degrees latitude north. Okay, so how do you do that? So I drew myself a little picture of the Earth. Okay, we are told that the radius is 3,960 miles. Okay, so we were already given that previously. Okay, so 3,960. If I'm 45 degrees latitude north? Okay, how far is it around the Earth? As you can see, when I'm up here, it's not as much as at the equator, right? The equator, you're going to get the biggest circumference. But if I'm at 45 degrees, what is it? Okay, just so you know, what are we like? In San Francisco Bay Area, it's, I think, about 37 degrees. We're about 37 degrees north. So 45 degrees is a little bit higher. I believe it's maybe Portland, Oregon, somewhere around there is 45 degrees. Okay, but San Francisco Bay Area is about 37, I think. All right, so I drew myself this picture. Here's 45 degrees. Okay, and I want to figure out this new radius, which I'm going to call x. Distance from here to here, that's x. Okay, and you can see from the picture, the cosine of 45 degrees is x over the hypotenuse, which is the radius. Radius, of course, is the same anywhere on a sphere. So cosine 45 degrees is x over 3960. Okay, so this hypotenuse is 3960. So punch out in a calculator, it's 2,800 miles. Okay, so this radius, if I'm 45 degrees latitude north, the radius going all the way around is only 2,800 miles, not 3,960. Which means if I go around the Earth, of course, it's not going to be as much. Okay, then I use the formula for circumference. Circumference is 2 pi r. So 2 times pi times 2,800. Okay, punch it in a calculator. About 17,594 miles. Okay? So if I go all the way around the Earth, but at 45 degrees north, I'm only going 17,594 miles. That's as opposed to at the equator, right? At the equator, what did I say there's about 25,000 miles. So it's about 25,000 miles around the Earth if you're at the equator. If you're up at 45 degrees north, it's only 17,000 whatever miles. Okay, so here's the picture again. 45 degrees north means that. This is the new radius, x. I bring that over here so I can get this picture. And then the cosine of 45 is the adjacent over the hypotenuse. So that led me to what I needed. Okay. So that's that one. Okay, and a couple more word problems. Problem 21. The angle of elevation to the top of a building is 30 degrees. So angle of elevation when you're looking up at a building, okay, angle of elevation, 30 degrees from the ground when viewed 1 mile from the building. Estimate the height of the building in feet. Okay, so here's the picture. All right, now, this may or may not be common knowledge. You can always look it up. But 1 mile is 5,280 feet. Okay, you can put that on your cheat sheet if you need it. Okay, so if you've gone 1 mile, it's 5,280 feet. The angle of elevation, so if you're looking up at the top of the building, it's 30 degrees. Okay, so here's my picture. And we want to know how high this is. Okay, so here's 30 degrees. This is the opposite side. This is the adjacent side. So which trig function has opposite and adjacent? Tangent. TOA, T-O-A. Tangent is opposite over adjacent. So the tangent of 30 degrees is opposite x divided by 5,280, the adjacent side. And multiply both sides by 5,280. So x is 5280, tangent of 30 degrees. Punch it in your machine. It's about 3,048 feet is the answer. Okay, so this building is 3,048 feet high. Okay. And of course, make sure that you're in degree mode when you do this one. Okay, so we will have to bounce back and forth between degrees and radians. Make sure you're comfortable on your calculator, right? That you can do degrees or radians, either one. Okay. All right, then 25, and then that's all I was going to do for 4-3. 25. Again, let me show you the problems again in case you didn't get it. Okay, so page 206. For those of you that don't have the book and aren't getting it, there's those problems. There's those problems. Next page, 207. Okay, so again, when you look at the video, just go forward or backward or pause as much as you need to. Okay, from the top of an observation tower, a forest ranger spots an illegal campfire. The angle of depression made by the ranger's line of sight and campfire is 10.5 degrees. Okay, I'm not sure you can see it that well. Angle of depression means you're looking down. So you're up somewhere and you look down at something, like looking down at the Grand Canyon. Okay, so I'm not sure you can see it, but there's a line of sight here, and he's looking down 10.5 degrees. The tower is 80 feet high. How far is the campfire from the base of the tower? Okay, so here's the picture. All right, so this is 80 feet high. This angle here is 10.5 degrees, it says. So how far away is the fire from here to here? Okay, so here's 10.5 degrees. That's the angle of depression. You're looking down at something. Okay, again, this is the opposite side. This is the adjacent side. So I'm using tangent again. So tangent of 10.5 degrees is 80 over x. Okay, multiply both sides by x. X tangent of 10.5 is equal to 80. Divide both sides by tangent 10.5. So x is equal to 80 over tangent 10.5 degrees. punch it in your calculator, it's about 432 feet. Okay, so the fire is about 432 feet away. Right, and I think hopefully you can see one of the powerful uses of trig. You can measure distances without actually measuring. In some cases, it's too difficult. You know, nobody wants to walk out to a fire and measure stuff. But using trig, you can find distances by making use of trigonometric relations, right? Okay, so doing stuff like this, trig allows you to measure distances without actually measuring it. Okay. All right, I'm done with 4.3, folks. Okay, so I'll sneak in some introduction of 4.4, and then I'll be done, and then I'll let you ask questions. And when questions stop, then we're done for the day. Okay, then I'll see you again on what, Friday, not tomorrow, right? Okay, so introducing 4.4. I'm now done with this and this. Introduction to 4.4. It just makes it easier for me on Friday. And besides, I have to make sure I give you enough time for the quiz on Friday also. Okay. So 4.4, topic is the sine and cosine functions. Okay, and once again, let me show you the homework problems for the benefit of those of you that don't have the book and aren't getting it. So 4.4, 1 to 55. So let me go to the homework section. Okay, so page 219. Okay, so here's a bunch of problems here. Up to about 47, and then the bottom. Okay, and I think that's it. We had to go to 55, right? And there's 55, you see it. So that's all the page you need. So yeah, you don't need anything else there. Okay, so some introductions to sine and cosine. In theory, everything here is review. So page 208, you have yourselves a unit circle. Okay, what is the unit circle? It's a circle centered at the origin with a radius of 1. So this is the point 1, 0. They don't label it here. That's 0, 1, negative 1, 0, 0, negative 1. Okay, and if you have an angle in standard position means this direction is considered 0 degrees or 0 radians, and positive is this away, counterclockwise. If you go clockwise this way, that's considered negative. Why? We said so. We all agreed that's what we do. Okay, and then if you have some angle, technically in radians, okay, then the cosine of the angle gives you the x-coordinate. The sine of the angle gives me the y-coordinate. Okay, so sine of t is y, cosine of t is x. So x is cosine t, y is sine t. Now again, because we're under COVID and all that stuff, you can put it on your cheat sheet. Well, otherwise, ordinarily, I'd make you guys memorize it. The memory trick I would have is alphabetical order. X is before y in the alphabet, and cosine is before sine. Okay, so x handles cosine, and y handles sine. So x comma y is cosine comma sine. It's alphabetical order. Okay, so to give you a bigger picture here, I suppose. Okay, so we have an angle theta. Okay, then the x-coordinate is cosine theta. The y-coordinate is sine theta. Okay. All right, then on this page, okay, the way the author writes it isn't conventional, actually. This is correct. We know that sine t squared plus cosine t squared equals 1. Normally, you put the 2 right here and here. So it looks like sine squared t plus cosine squared t equals 1. And I'll show that to you. This is what I have. Sine squared t plus cosine squared t equals 1 means the same thing as this. Sine of t squared plus cosine of t squared is equal to 1. Okay. So I will normally write it like this. That's the usual way to write it. All right, and then we have bounds on the sine and cosine. Since we're talking about x and y coordinates on a unit circle, well, the x values are stuck between -1 and 1. Y is also stuck between -1 and 1. So that means for any real numbers t, sine of t is between -1 and 1, including -1 and 1. Likewise, cosine is stuck between -1 and 1, including -1 and 1. That's not true for tangent. Tangent can be any real number. But sine and cosine are both stuck between -1 and 1. Okay, and now about the sines, S-I-G-Ns. Okay, well, it depends on what quadrant you're in. Now, what the book has here is correct. I'll show you my version. Some of you may have heard this mnemonic trick, memory trick before. Okay, ASTC. Sometimes the memory trick is all students take calculus. ASTC. Again, if we were meeting face-to-face, I'd make you guys memorize it, but since we're not, you won't. Okay, so what does this mean? Okay, between sine, cosine, and tangent. Only sine, cosine, and tangent. See, what about secant, cosecant, and cotangent? Well, the reciprocal of a positive, if you flip a positive number over, it's still positive. And if you flip a negative over, it's still negative. Okay, so for secant, cosecant, and cotangent, just follow the signs, S-I-G-N, of the reciprocals. So what does this mean? This means in the first quadrant, all three trig functions, sine, cosine, and tangent, are positive. They're all positive. Second quadrant, the sine is positive, S for sine, which therefore means cosine and tangent are negative. Third quadrant, T for tangent. Tangent is positive, therefore sine and cosine are negative. And C is for cosine. Cosine is positive. That means sine and tangent are negative in quadrant 4. Okay, so that's what all this means. Okay. So I wrote all students take calculus as a memory trick. Since you can put it on your cheat sheet, you don't have to memorize it. But there it is. Okay, so just between sine, cosine, and tangent. Sine, cosine, and tangent. Which ones are positive? First quadrant, all of them. Second quadrant, only sine, which means cosine and tangent are negative. Third quadrant, only tangent is positive. Sine and cosine are negative. Fourth quadrant, cosine is positive. Sine and tangent are negative. Okay. So that's what we have there. All right. It turns out the cosine function is even and the sine function is odd. So cosine of negative t is the same as the cosine of t. Sine of negative t is equal to negative sine of t. Okay? So if you have the cosine of negative an angle, it's the same as the cosine of an angle. That's always true. Sine of negative an angle is the opposite of the sine of the angle. Okay? So just for fun, let me type out something here. It doesn't really matter what mode you're in. So I'm in radians. I hit cosine of 1 radian, 0.54 or whatever. And I'll hit cosine of -1. And I get the exact same number. See that? Cosine of 1 radian, 0.540. Cosine of -1, same thing, 0.540. Okay, so cosine of negative an angle is the cosine of an angle. That means the cosine is even. So for the graph of the cosine function, it would be symmetric with respect to the y-axis. It would have y-axis symmetry. The sine of negative an angle is the opposite of the sine of an angle. Okay, so let me hit sine of 1 radian, 0.84 something. So according to this theory, if I hit sine of -1, I should get negative 0.84, whatever. Okay. Sine -1. Sine of -1. And there it is, negative 0.84, blah, blah, blah. Everything else is exactly the same. Okay. So sine is an odd function, which means it will have symmetry with respect to the origin. It will have origin symmetry. All right, then a little table here. And again, if you want to put it in your cheat sheet, you may, or think of the unit circle. If we were meeting face-to-face, I'd make you guys memorize it. But a little chart for 0, pi over 2, pi, 3 pi over 2, 2 pi. Now, hopefully, you're somewhat familiar with these angles. Here's 0. If I go all the way around, it's 2 pi. So if I cut that in half, that's pi. If I cut that in half, that's pi over 2. So this is 0, pi over 2, pi, 3 pi over 2, 2 pi, right? 0, pi over 2, pi, 3 pi over 2, 2 pi. Or if you like, 0, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. All right, cosine controls the x-coordinate. So let's look at the x-coordinate along the unit circle. So what's the x-coordinate? 1. X-coordinate, 0, pi over 2. Pi, x-coordinate, -1. 3 pi over 2, x-coordinate, 0. 2 pi, that means you go all the way around the circle once, x-coordinate, 1. See how it works? So the cosine of the angle says, just give me the x-coordinate on a unit circle. What does the sine give me? Sine of an angle gives me the y-coordinate. So as I go around a unit circle, let's look at the y-coordinate. So sine of 0, y-coordinate, 0. Pi over 2, sine of pi over 2, the y-coordinate, 1. Sine of pi, that means I'm coming all the way here, 180 degrees, y-coordinate, 0. 3 pi over 2, 3/4 of the way around. What's the y-coordinate? -1. And then 2 pi, I'm back to where I started from, all the way around. What's the y-coordinate? 0. Okay, so there we go. So you can put it on your cheat sheet, I suppose, or think of the unit circle. That's over here. Again, both sine and cosine are what's called periodic functions. There's a repeating pattern. Okay, so P of t plus 2 pi equals P of t. P stands for the point. So if I'm at any point, right, if I add 2 pi radians, you're just going around a circle one more time, so you're going to land at the same spot, right? So P of t plus 2 pi is equal to P of t. Okay, so that means sine of t and sine of t plus 2 pi, that's always going to be the same thing. Likewise, cosine of t and cosine of t plus 2 pi is always going to be the same. Okay, so it's considered a periodic function. Okay, so a periodic function repeats itself. All right, then properties of sine and cosine. The periods for both of them were 2 pi, you might recall, because if I go around a circle once, that's 2 pi, and then it just starts repeating itself. Right? So both sine and cosine have a period of 2 pi. Okay. All right, then some special angles, pi over 4 and sine of pi over 4, cosine pi over 4. Okay, so we have already seen that before. Show you the picture right over here. Okay, so I showed you a unit circle before. It's going to be radical 2 over 2 for both of them. Okay, I showed you a justification of that. You put a 45-degree angle here, make it an isosceles right triangle, and you can prove that both of these are radical 2 over 2. And these are also radical 2 over 2, except second quadrant, x is negative, y is positive. Third quadrant, both x and y are negative. Fourth quadrant, x is positive, y is negative. Okay. So this is pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Or again, if you want to count by pi over 4s, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. And then you can reduce as necessary. So all of these are radical 2 over 2, except for the SiGN sign. Okay, so what are the sine of pi over 4 and cosine pi over 4? They're both radical 2 over 2. Top of 212. Sine of pi over 4 is radical 2 over 2. Cosine pi over 4, radical 2 over 2. Okay, then pi over 3, that's 60 degrees. So what they did was draw this kind of a picture. It's an equilateral triangle. I showed you the equilateral triangle before, right? Go like this. This is 60 degrees. And they drop a perpendicular, which means this cuts it in half. So each of these is a half, right? And then by using the Pythagorean theorem, you can find this to be radical 3 over 2. I showed that to you the other day. Okay, so I don't want to show it to you again. But this is going to be radical 3 over 2. Okay, so the distance from here to here is a half. Distance from here to here is radical 3 over 2. Okay. X coordinate is a half. Y coordinate, radical 3 over 2. So there we go. Sine of pi over 3, sine of 60 degrees, radical 3 over 2. Cosine of 60 degrees, cosine of pi over 3, 1/2. Okay, for 30 degrees, pi over 6, you just reverse them. You pretty much have the same picture. Just draw this picture back down over here. Okay, and now it looks like the y coordinate is half, which means the x coordinate is radical 3 over 2. Okay, so here's the sine and cosine of pi over 6. Sine of pi over 6, or sine of 30 degrees, is 1/2. Cosine of 60 degrees, 30 degrees, sorry, cosine of pi over 6, radical 3 over 2. And here's a nice little picture here within the first quadrant. Okay, so this is 0 degrees, 30, 45, 60, 90. Or in radians, not sure you can see that, that's 0 radians, pi over 6, pi over 4, pi over 3, pi over 2. Here are the ordered pairs associated with them. Okay, so at 30 degrees of pi over 6, radical 3 over 2, 1/2. Pi over 4, they're both radical 2 over 2. Pi over 3. Pi over 3 is the reverse of pi over 6. If that helps. So it's 1/2 radical 3 over 2. And then, but by the time you get to 90 degrees of pi over 2, it's 0, 1. That's that. And I'll show you my version of it also. And so I gave this to you before, but 30 degrees, radical 3 over 2, 1/2. 60 degrees, the reverse, 1/2 radical 3 over 2. Now, to me, you can get by without memorizing it if you just kind of draw yourself a unit circle and look at the picture. Okay, so at 30 degrees and 60 degrees, sometimes I just draw myself a picture. Then I say to myself, okay, I know one of the coordinates is a half. Okay, so look at the x coordinate. Does that look like a half? No, it looks like way more than a half. The y coordinate looks like it's a half. So that tells me to put a half here. 1/2 is always paired with radical 3 over 2. 60 degrees is the reverse. So from here, I go over to there and there. Does it look like x or y is halfway across the circle? Okay, look at this y value. It's way more than half. If you look at the x coordinate, okay, that looks like half. That means x is a half. Therefore, y is the other number, radical 3 over 2. Okay, if you punch out radical 3 over 2 in the calculator, it's like 0.866. I did it before. Okay, so it's way more than a half, as you can see. That's like 0.866. Okay. Well, I guess I can show it to you. Let me just show it to you. Square root of 3 divided by 2. Square root of 3 over 2, 0.866, something like that. Not sure you can see it, but you can do it for yourself. Square root of 3 over 2, 0.866, way more than half. Okay, yeah, I'm giving you a lot of background, even though I'm not doing any homework problems yet, but this just saves me time for Friday, okay? Give you all this introductory stuff. And one last thing, oh yeah, to give you the table here. Okay, so cosine of 0, pi over 6, pi over 4, pi over 3, pi over 2, sine of the same angle. So 1, radical 3 over 2, radical 2 over 2, 1/2, 0. The sign just reverses. It's like take all of these numbers and just put it backwards. 0, 1/2, radical 2 over 2, radical 3 over 2, 1. All right, then reference number or reference angle. The reference angle or reference number associated with T is the shortest distance along the unit circle from T to the x-axis. Okay. For any T, the reference number is between 0 and pi over 2. That means between 0 and 90 degrees. Okay, so they show you the 4 different quadrants here. And I'll show you the reference angle. Now, if you're in the first quadrant, you always go back to the x-axis. So I go back to the x-axis, and it's a number between 0 and 90 degrees. The reference angle is the same as the angle itself, which makes perfectly good sense. If you're already in the first quadrant, our favorite quadrant, why is it our favorite quadrant? Because everything's positive. The reference angle is the same as the angle itself. Okay, now if I'm in a second quadrant, then I want this angle. It's always an acute angle, number between 0 and 90 degrees. So this would be my reference angle. In the third quadrant, the rule is you go back to the x-axis as an acute angle. This angle here, right there, would be my reference angle. And in quadrant 4, this angle here would be the reference angle. So if you're following me in the text on page 214, it's the red part. The red part of the angle is the reference angle. Notice it's always between 0 and 90 degrees, or if you want to say in radians, between 0 and pi over 2. So first quadrant, the reference angle is the same as the angle itself. Second quadrant, this part in red. Third quadrant is this one. And fourth quadrant, this one. Okay. And what they have is correct. And do I have to memorize all that? I would say no. You don't have to memorize. If you want to, you may. Okay, because they got these different rules, 2 pi minus t and, you know, all this t minus pi. I would say don't even look at that. Just reason it out for yourself. Okay, just reason it out and say, okay, it's an acute angle. That's reference angle. That's reference angle. That's reference angle. Oops, sorry. This is reference angle. And this is reference angle. Okay. All right. And I think that's about it, folks. Okay. So next time, which is not tomorrow, Friday, I'll get started with 4.4. So even though I didn't do any homework problems with 4.4, I had to do all this groundwork, and all that groundwork that I did today means I'll have to do groundwork on Friday and just get started with the problems. Okay, so 4.4 on Friday, I'll get started with the homework problems, and then I'll stop and give you the quiz. Okay, and the quiz on Friday is most likely something like this, where I'll give you a triangle, I'll give you a theta, and I'll give you 2 of the sides. Of course, you have to figure out the third side by using the Pythagorean theorem, and then find the 6 trig functions: sine, cosine, tangent, secant, cosecant, cotangent. Okay. All right, so I'm done, folks. Let me stop the share and check the chat. And I see nothing in the chat right now. Okay, so does anybody want to ask me any questions? And if not, we're done until Friday. Okay, so you can either unmute yourselves and say something, or you can put it in the chat. But if not, we're done. Anybody have anything? Okay, I don't hear anything. All right, so have a good day. Enjoy your, what do I call it, a one-day weekend. Enjoy your one-day weekend tomorrow, and we'll see you again on Friday. All right, thanks, everybody. Bye.